So far in this series, our recommendations have primarily been based on improving air quality. From optimizing airflow and pressure, to reducing moisture, to filtering the breathing air itself, we have been solely focused on improving air quality by the time it reaches your blast pot, the heart of your blasting system. So at this point, the question is, does your blast pot have restrictive or non-restrictive piping? You see, we've taken steps to ensure high-flow compressed air is delivered to the pot through a 2-inch bull air hose to optimize CFM. But what size pipe fittings are now handling this flow? Is your air supply now choked by being squeezed through a 3/4 inch or 1-inch fitting? A good blast pot has large bore pipe fittings with a minimum of elbows and bends. Get a needle pressure gauge and compare the air pressure just before the pot and then just after. You should have a maximum of 3 psi pressure drop across the pot. Warning, some manufacturer pots come with a 10 psi drop because of complicated pipe and valve configurations. And remember, 1 psi equals 1.5% performance drop. This 10 psi drop is immediately making your blasting efficiency drop by 15%. That means if you could blast 300 square feet per hour at 100 psi, losing 10 psi via your piping down to 90 psi would now drop productivity to 250 square feet per hour. That's a 50 square foot per hour loss. If the goal is to achieve at least 6 hours of actual blast time per day, the 100 psi setup would accomplish 1,800 square feet, while the 90 psi setup would accomplish 1,500 square feet. In other words, the higher pressure delivers an extra 1.2 hours of productive labor each day. The Performance 3 recommendation here is simple. Your blast pot should utilize valves and pipework that do not restrict airflow. We recommend uncomplicated plumbing. The fewer angles and bends, the better, as well as the following piping diameters: 1 1/4 inch for number 6 and 7 nozzles, or 1 1/2 inch diameters for number 8 nozzles. We lose much of the positive effort we've put into selecting our compressor and hose sizing if at the heart of your blast setup, we now choke that air with undersized plumbing.
I went to visit a client in Central Ohio, and we found that they were using very restrictive controls on the pot. And it was an older style pot, very commonly used in the industry over the last 40 years. Controls that haven't been upgraded since about 1960. And so we decided to do a pressure check to see how much pressure loss we were getting over the pot. So we had a 450 CFM compressor, and we had 110 psi coming in the pot and 90 psi coming out of the pot. There was a 20 psi reduction. Why? The air has to get through a series of valves that is very restrictive. So we then upgraded them to a full flow Schmidt system, which has 1.5 inch flow the whole way through, and reduced that pressure loss down to only 2 psi. That was an increase in pressure by 18 psi just by changing out the valving system on that blast pot. That resulted in a 27% production increase.
There are a couple more Performance 3 recommendations while we're focused on the blast pot. Next, let's talk about maximizing the use of this equipment each day.